Hello friends, welcome to a new video of this Carla series, and now we are with our collision test part 2. So here we are just going to add a few functionalities. So I'll just okay, let's get the comments out so we can concentrate on the main code. So today our focus is on this function. So without wasting any time, I'll just give you a brief introduction about these all jumbled code, and now I'll just start with that part. I'm very excited to start with that part. So let's get started. So we are importing few modules. We are getting the EGG folder of Carla. Okay, we are importing Carla from that, and we are getting the start time, like when the program starts. So it will mark a flag like, yeah, the time got started. This will be discussed later with that part which I highlighted earlier. Then actor list is for all actors which you have created. Car control. Okay, so you understand like the car is going straight, then it will turn like left, right, and then it'll crash. Like, so we can actually get a collision. Like you can't always get a collision with cars. So to make the collision event like more like inevitable. So I just did like this is done, and then we are calling the Carla from the local host 2000 port. Then we are getting model 3 from the blueprint library. Then we are spawning it. We are adding the yaw, roll, and pitch of the like collision sensor, not the camera. So don't get confused with the variable name. Then we are setting the transform. We are appending it in the drop vehicle, and then okay, let's discuss this part. This is little important. So we are calling the collision sensor using the sensor.other.collision and get blueprint of the world.find function. So we are passing this as an argument. So this will give us a collision sensor which we are spawning and attaching to the car. If you see in this line, and we are calling the sensor.listen. So listen is a Carla inbuilt function. So whenever a collision happens, it will give us the data of the collision. So the data will be stored in this data variable, and using the lambda function, we'll just call a on collision function, and we are going to send this data as an argument. So the on collision function is discussed now down. So we first will blindly print there's a collision because census.listen returns data only when a collision happens. Then we are going to get who had collided with this, so we need to know who had done that. So we'll get the actor display name function, and we'll send the data dot other actor. So what is other actor? So in the collision sensor also returns what actor had hit the car. Like here in our case car. So now because we have attached the collision sensor to the car, so we get the actors which have hit the car. So that's a thing point to be noted. So what is the other actor? So data from the sensor or listen has few attributes like other actor, normal impulse, and distance and all that. So time, and also we are going to get this, and we are going to like it returns some data. That's why we are using listen function. So that these are the data points. So what is this get actor display name? Okay, so like control. Okay, so this is not Visual Studio, so control click doesn't work. Yeah, just minimize this. This is disturbing. So we are calling the collider like, and then with space we are going to join it, and data dot type id. So from that, so from the data here is not a data. So here the data means data dot other actor. So what is actually coming from the lambda function? We are getting the data. That data's other actor dot type id. So it actually it's the data from the like sensor dot other actor dot type id, and we are replacing the underscores or dots like you see here dots sensor dot other dot collision. So we are going to replace them with like the title notation, and we are going to split by the thing like this dot, and we are going to replace them by space, and we are going to slice it from the first. So as it starts from zero, so we'll get rid of this sensor. Like this is the main hierarchy of the thing. So from the sensor, we have a others tree. From that others tree, we have the collision sensor. So we're just going to remove the sensor. We'll be like other collision. We'll be like model 3 a vehicle dot Citroen dot model 3. So it will just give Citroen model 3 like that. So you try to understand the way it's going to denote the name after this. So then we are returning the collider. Then we are printing the thing, like the collider actor. Then we are getting the collision event record equals to data dot normal impulse. So data dot normal impulse will have the impulse created on the collision sensor in the x y z vectors, like, or the axes. So how do you find the actual intensity, like approximate intensity irrespective of the vectors, like as a total? So here we are going to make a approximation. So from that data to normal impulse, we are calling the x, y, z vectors, and we are squaring them, like asterisk means a square. We are adding these three results and we are doing the square root function. So this will give us the approximation. Then we are printing this. Then we are minusing the time dot time, like the present time minus start time. So it will give us the like after how many seconds, or the duration after which the collision happened, and we are applying the brakes. Like after collision we need to stop the vehicle. There is no meaning of just getting the vehicle into the actor. So now let's get started. Like I have the things ready, so I'll just spawn few cars. So I have the thing ready. So we are going to do three test cases here. The 40 car test, 50 car test, and 100 car test. So you see cars got spawned, and now you'll just see the console. Oh yeah, pole. Collision with pole. Intensity is this after 10 seconds. So I'll just now control C. So now we are going to keep this data here, like collision with pole intensity this. So intensity is 16774. Like uh though I can't give you the units, like I don't know what units it calculates. So yeah, there was a collision, yes. And then after how many seconds? So instead, I would like to paste this data also. Collision with pole and intensity of the collision was this. And then how many seconds? I'll just copy this thing. Sorry, it was the ever part 10 point this thing. So you see, as the vehicle is moving, we had a more intensity, but as it stopped, we have a less intensity, like of the crash. So like it also satisfies our physics knowledge. Like if you like, guys, I have to print copy it again. I just, yeah. So this is a record. Like we're just maintaining record of what we are doing. So now we are going to do a 50 car test. So we have to run in codes and all that. So yes, so 50 cars. Okay, okay. I kept it. Yeah, now. So this will spawn the cars. We'll run the code again. And I know it will just crash in the same pole as it will. It's never going to collide with the car. Huh? It didn't. So it will collide with the wall. So you see, collision happened after the collision is there. I'll just collision audiatron. No, what so it collided with a car. I think I did not see. So I think from back it got collided with car, this car, and then it got with in the wall. So I'll just take the audiatron case. So and I'll just get this. So I think I missed seeing that, and then I'll just paste it, and then what's the time? 6 seconds. I'll just copy this. So I'll just keep here yes, and yeah. So this is the thing. Now last case, which is 100 cars. Nothing special. So instead, I'll just try to change the spawn point to make it things go interesting. I'll just set the spawn point to some random 34. Yeah, that will work fine. Like if you don't spawn the car in new places, then it's going to hit the same thing. Like here, because it hit the car, it hit the like it got little push, and it hit the wall. But it's not what's going to happen in all the cases. So yeah, So 34 is this. Yeah, it's my favorite place. There's very less chance of collision, I feel. Yeah. Okay, I thought it will hit the actor. Like, so it's just going on rotating. And so actually, there was no collision here. Okay. But no, we want a collision. So until we get a collision, we'll just do the. Yeah, we want a collision. Yeah, it will, no. So again, it will go around the circle, I think. In this case, also, we'll not get any collision. So I'll just rerun this. And I'll just make a clear screen. Then I'll just run. I want collision. So yeah, this is the perfect chance it will collide. So you see, collision with bike. So collision with Kawasaki Ninja. So that's the name of the bike. And the collision was like, yeah, it's 3414. Yeah, like it's a tough collision, like. And then the time which we are just keeping a record just like that. Like there is no intention of keeping the record, just to see how things go about when they collide. So yeah, so I'm missing the track. Yes. Like we always give a yes. We don't go for a no. That's why it's yes. And now this. So you see, we can compare all the six collisions. And here in 456 you have extra data. So this is somewhat helping us. So this is what collision sensor is, and that's it for the video, friends. Thank you, friends, for watching the video, and stay tuned for more videos on Carla. Thank you.